So, hello students. Hope I am audible to you. Okay. So basically, let me introduce myself. My name is Avinash, and I'm a biology faculty at askIITians. So, guys, today we'll discuss about the NEET exam paper. Okay, we know recently we finished our NEET examinations. So here we will discuss about the questions and their answers in this sessions. So let's start. So in this first sessions, this is the first part of biology discussions. And in this session, we will try to cover 33 questions. And from next onwards, we will also have our next basically videos for this discussions. Okay.
Velocity but varying acceleration. Okay, see, acceleration will change because the direction is changing, but again velocity will also change because the direction is changing. So over here the answer will be the fourth option, that is varying velocity and varying acceleration. Clear? Simple. Okay. Okay, now exactly comes the next question, that is from logical gates. Now, in this particular question, what they have given, this is A, this is B, this is Y. So this is 0, 0, 1, 1. This is 0, 1, 0, 1. Okay, and Y is 1, 0, 1, 0. And the options are A dot B plus A bar. Okay, or I can go with A dot B bar plus A bar. Or third option is B bar, and the fourth option is B. So these are your four options. Okay. Now see exactly if I'm considering this particular option. So obviously B and Y both are opposite. So this cannot be the answer. Okay. See, when B is 0, Y is 1. When B is 1, Y is 0. B is 0, Y is 1. So obviously this can be the answer. Okay, so I'll keep it TK. Chalo, this is confirmed. Now see, obviously it's in a NEET exam, so you don't have multiple choice questions. So if you're definite that this is the answer, then I don't have to check A and B. So I'll simply denote that my answer is C. Clear, everyone? Okay. TK. Now let's talk about the next question, that is question number 4. Okay, now see, the question number 4 is, okay, they have given two solenoids. Okay, that is solenoid AB and solenoid CD. Now what they are saying that in the above diagram, a strong bar magnet is moving towards solenoid 2 from solenoid 1. The direction of induced current in solenoid 1 and that in solenoid 2 respectively are through the directions. Okay, so see exactly, if you try to observe that this is your solenoid A, B. Okay, and this is your solenoid C, D. Okay, and this is that bar magnet, north and south. Okay, now exactly let's talk about this. So see, if you remember, okay, for example, if this I'm considering as a solenoid, okay, if this is your solenoid, the simple concept was if this is a bar magnet, north, south, and if this bar magnet is moving towards the solenoid, such that the north is moving, so the direction of that can be given by simply plotting N inside it like this. So technically the direction is anti-clockwise when north is moving towards it. So obviously if north is moving away, the direction will be in this condition, that is the clockwise direction. So if I'm talking about this AB, the direction is clockwise. Similarly, the south is moving towards that. So on that basis, if you're talking about the directions in AB and CD, so technically it would be AB and DC. This would be the flow of current. This would be the flow of current. Clear? Okay, simple. Now let's talk about the next question. That is question number 5. Okay. Now when I'm talking about the question number 5, What they have mentioned is that given below are two statements, one is labeled as assertion and the other is labeled as reason. Okay, now let's talk about. Now see, when I'm talking about assertion and reason, you have to check whether they are both are correct or not. So first of all, I'll be checking whether both are correct or not. Second thing, I'll be checking whether they are relevant with each other or irrelevant with each other. Okay, so when I'm talking about the assertion, what they have stated over here, the potential at any axial point at 2-meter distance from the center of the dipole of a dipole moment vector magnitude, okay, 4 into 10 raised to minus 6, no, sorry, 4 into 10 raised to minus 6 coulomb meter is plus or minus 9 into 10 raised to 3 volts. Okay, so see the potential along the axis they are asking. Now, if you're talking about the potential, the formula is given as Kp upon r square, if you'll remember this. Okay, or you can go with 1 upon 4 pi epsilon naught p by r square. Obviously, on the equator, the potential is 0. So if you're trying to solve this particular equation, okay, I can go with the formula that 9 into 10 raised to 9 into. Now, they have given the dipole is 4 into 10 raised to minus 6. Okay, upon r is how much? 2 meters. So 2 square. So technically this term and this term gets cancelled and your answer is 9 into 10 raised to 3. So technically assertion is correct. Now let's talk about the reason. V is the 2p upon 4 pi epsilon naught r square. No, the formula is incorrect. The formula is kp by r square. So over here, assertion is true. Okay, assertion is true. And the reason which they have mentioned, that is false. Clear? Okay, so this is your question number 6. Sorry, question number 5. Okay, now moving on to question number 6. Now question number 6 is match the following. Okay, obviously the topic belongs to magnetic materials. Okay, in the first column they have given diamagnet, ferromagnet, paramagnet and non-magnet. Okay, and in the second one they have mentioned the value of chi, that is chi is equals to 0, chi is between 0 to minus 1, chi is much greater than 1. Okay, chi is between 0 and epsilon, where okay is a positive number. Now see, first of all, if I am saying that chi is much greater than 1, so obviously this belongs to a ferromagnetic material. Okay, this is the condition of ferromagnet. Now obviously if this is the condition of ferromagnet, matlab B corresponds to third. Now see, in match the following, it's very simple. You don't have to check all the 4 options. You can just evaluate first and second, and on that basis, okay, I can mark the answer. Now B responds to third, so that option belongs to the first and the fourth. Well, definitely the answer will be the answer will be the option A or option B. Now moving on to the second one, when I'm talking about diamagnet. Now see, what is the property of diamagnet? It repels in a strong magnetic field. It means that when I'm considering a diamagnetic material, okay, so its chi should lie between 0 and minus 1. Why? Because it repels. So A corresponds to the option number 2. Now let's check. A corresponds to option number 2 and B corresponds to option number 3. There is only one option which satisfies both the conditions. So over here, your answer is option A. Clear? Simple. Okay. Okay. Now moving on to the next question. Okay, that is question number 7. Now exactly when I'm talking about this question, they have mentioned that in a uniform magnetic field, okay, 0.049 Tesla, okay, is your, in a uniform magnetic field, this is the value of, okay, A needle performs 20 complete oscillations in 5 seconds as shown. It means that the number of oscillation is 20. So if I'm talking about the time period, the time period is nothing but time taken for one oscillations. So in 5 seconds it performs 20 oscillations. So 5 by 20 will be your time period. That is time for one oscillation. Okay, total time upon total number of oscillations. The moment of inertia of the needle is 9.8 into 10 raised to minus 4 kg meter square. Okay, so they have given you the moment of inertia mi. That is 9.8 into 10 raised to minus 6 kg meter square. Okay, if the magnitude of magnetic moment of the needle is, matlab they have given you the value of magnetic moment m, that is x into 10 raised to minus 5, and they have asked what is the value of x. Simple. Okay, now obviously this question corresponds to the condition that time period is equals to 2 pi by omega. Now this is nothing but rotational SHM. Now if you'll observe in rotational SHM, okay, we also had that condition that time period can be given as 2 pi root of, okay, apna, yes, 1 minute. Omega square is equals to k by m, or instead of that, instead of k, I'll be writing c, and instead of m, I'll be writing as I. So I by c, where c is called as torsional constant. Okay. Now, if you'll try to compare this equation, can I write torque is nothing but mv sine theta, or it is equals to c theta? Okay, and if theta is very small, okay, then sine theta is approximately equals to theta, and mv is equals to c. Clear? Okay, so based on that, the time period can be given as 2 pi root of I upon m. Clear? Okay, now they have asked what is the value of m. So can I go like this, that t square is equals to 4 pi square into I by md, or m is equals to t square into b upon 4 pi square into I. And now the value of t is, that is 5 by 20, that is 1 by 4. Okay, so this becomes 1 by 4 the whole square into, now v is 0.04 upon 4 pi square into, moment of inertia is given as 9.8 into 10 raised to minus 6. So 9.8 into 10 raised to minus 6. Now see, in the options, if you'll see, all the option consist of pi square. So obviously they haven't evaluated the value of pi square. They have kept it as it is. Okay, oops, sorry, my mistake, my bad. Okay, just a sec. This m will be 4 pi square into I upon t square. Sorry. So this becomes 4 pi square into 9.8 into 10 raised to minus 6 upon 1 by 4 the whole square into, the value of b is 0.0. Clear? Okay, now if you solve this one, so this entire value comes approx to be 1280 pi square into 10 raised to minus 5. So this corresponds to the value of x. Clear, everyone? Okay. Okay, now moving on to the next question, that is question number 8. Now see, when I'm talking about question number 8, the question is very simple. What they have mentioned over here, in an ideal transformer, the ratio of the turns is 1/2. The ratio of the potentials equals to. So obviously the potential is inversely proportional to the number of turns. So if the ratio of turns is 1/2, so the ratio of potential becomes 2/1. That's it. Okay, so your answer will be 2/1. Clear? Okay. Now moving on to the next question, that is question number 9. Oops, just a sec, sorry. Okay, potential is directly proportional to number of turns. So Vs upon Vp is equals to Ns upon Np. My bad. Okay, now they have given you the value of Np by Ns, that's 1/2. So this value becomes 2/1. So this will be your answer. Okay, now moving on to the next question, that is question number 9. Now question number 9, what they have mentioned, that in a vernier caliper, in a vernier caliper, n+1 divisions of a vernier scale coincides with n divisions of the main scale. Okay, if 1 MSD represents 0.1 mm, the vernier constant is. Now see, for this we have directly the formula. The vernier constant will be 1/100 n+1. Okay, no need to solve. Okay. Now moving on to the next question, that is question number 10. Okay. Now see, question number 10 belongs to laws of motion. Okay. A horizontal force 10 Newton is applied to a block A as shown in the figure. So see, in the figure what they have mentioned is that this is your ground. Okay, this is your block number 1. Okay, and this is your block number 2. This is 2 kg. This is 3 kg. And over here, I am applying a force of 10. Okay. The mass of block A and block B are 2 and 3 kg. The block slides over a frictionless surface. The force exerted by block A on block B is. It means that they are asking you the normal reaction. Now see, if you're trying to plot the free body diagram, the free body diagram will be very simple. That this is 2 kg. This is 3 kg. Let's say this is the force applied. Sorry. This is the force applied over here. This will be the normal reaction. Over here, this is the normal reaction. And they both will move with the same acceleration. Now see, if both are moving with the same acceleration, so can I simply say that F is nothing but MA plus MB into A. That becomes 10 is equals to 5A, or A is equals to 2 meter per second square. Now in this, if you want to draw the equation, F minus N is equals to MA and N is equals to MA. Okay, now you have the value of acceleration, so your normal reaction becomes 3 into 2, that is 6 Newton. Okay, so over here the answer is 6. That's it. Clear? Okay, that is your option number 3. Okay, now moving on to the next question, that is question number 11. Okay, now see, when I'm talking about this question number, that is question number 11. The question number 11 states that, okay, what exactly they have given in the question is, x is equals to 5 sine pi t plus pi by 2. X is equals to 5 sine, okay, pi t plus pi by 2. Pi t plus pi by 2 represents the motion of a particle executing SHM. So basically this is nothing but equation of simple harmonic motion. Okay, now when I'm talking about SHM, the amplitude and time period they have asked. So see, this question is in meters. Okay. So if you try to compare this with the general equation, that is x is equals to a sine omega t plus alpha. So technically a is equals to 5. That is confirmed. Now time period is 2 pi by omega. If you'll observe over here, omega is pi. So if I'll substitute that, t is equals to 2 pi by pi. Okay, the t becomes 2 seconds. So your answer is amplitude 5 meter and time period 2 seconds. So basically, which is the option? That is the second one. Okay. Okay. Now moving on to the next question, that is question number 12. Okay. Now see, in question number 12, again they have specified assertion and reason type questions. Okay. Now the question is, the terminal voltage of the battery whose EMF is 10 volt and internal resistance is 1 ohm when connected through an external resistance of 4 ohm as shown in the figure. Okay, so no, sorry. Question number 12 is your numerical one. Okay, what they have asked, the terminal voltage of the battery whose EMF is, they have asked the terminal voltage. Now see, when I'm talking about the terminal voltage, the terminal voltage means what? Matlab the voltage across the external resistance. So over here, this is 4 ohm. Okay, this is the battery. This is 1 ohm. Okay. Okay, and this is 10 volt. Now moving on this, so your total resistance, or you can go with EMF induced, is nothing but I capital R plus small r. That is 10 is equals to I 4 plus 1, that is 5. So your I becomes 2 ampere. And V is nothing but capital I into capital R. That is 4 into 2. That is how much? 8 volt. So is there an option of 8 volt? Yes, the third one. So the first option is 4 volt, 6 volt, 8 volt and 10 volt. So your answer becomes 8 volt. Clear? Okay. Now moving on to the next question, that is question number 30. Okay. Okay, question number 13. Now question number 13, this statement, atoms are electrically neutral as they contain equal number of positive and negative charges. So obviously we know that, okay, if you're considering an atom, okay, not ion, cation, anion, nothing, pure atom. So the atom has the same number of protons and same number of neutrons. That is the reason they are electrically neutral. After reaction, there is a possibility that it will transfer some of the electrons, protons, okay, electrons. Because of that, it might gain a positive charge or negative charge. So that is the secondary aspect. In general, it is always neutral. Okay, the second statement is, atoms of each element are stable and emit the characteristic statement. In the light of above statement, choose the most appropriate answer from the options given below. Okay. Now see, atoms of each element are stable. That is actually not possible. Okay, there are n number of options you can go with. Just for example, if I'm talking about the radioactive elements, they are not stable. Okay, also let's talk about sodium. So we know that sodium is highly reactive. Okay, matlab if you keep sodium anywhere, it will react with the other atoms. So technically, the atoms are stable, and obviously that statement is not correct. So I can go with the third option, that is statement 1 is correct, but statement 2 is incorrect. Clear, everyone? Okay. So statement 1 correct. Okay. Statement 2 incorrect. Clear? Okay, now moving on to the next question, that is question number 14. Okay, now see, exactly when I'm talking about question number 14, in the question number 14, they have mentioned the question from modern physics. So if c is the velocity of light in free space, the correct statement about photon among the following are: the energy of photon E is equals to h nu. Okay, the velocity of photon is c. Now see, we know that the energy is given as h nu, or it is also given as hc by lambda, where c is the speed of light, or c is nothing but speed of photon. So technically A and B both are correct. Okay. Now if I want to observe A and B only, so the first option satisfies the condition, the second and the fourth. I can eliminate the third option. Now moving on to the third option, what is it? The momentum of a photon is h nu by c. Okay, so now see, when I'm talking about momentum, okay, now what is momentum? Momentum is nothing but you can give the momentum by the formula that kinetic energy is equals to p square by 2m. This is one option. The other option you can go with kinetic energy is equals to half mv square. Okay, or in the case of photon, this can be written as mc square. So basically, mc can be one per momentum and c remains. And over in place of energy, I can write h nu. So your momentum becomes h nu by c. So obviously, c is also correct. Okay, so which option satisfies all the three conditions that A, B, and C are correct? That is the only option, that is option number 2. Okay, the option number 2 says that A, B, C, and D are correct. So I can mark the option number 2. Clear? Any doubt in this? Okay. Okay. Now, moving on to the next one, that is question number 50. Okay. Now, see, when I'm talking about question number 15, what they have stated over here, the spectral lines of hydrogen for transition from n1 n2 is equals to 3 to n1 is equals to 2. They have considered the various parameters. That let's say that it is jumping from second to third, fourth to third to second, fourth to second, fifth to second, and sixth to second. Okay. Now, on this basis, what they are asking, calculate the wavelength. Now, you have to evaluate the value of the wavelength. Okay. Now, moving on to this particular condition, I can go with the equation that 1 upon lambda is equals to R 1 upon n2 square minus 1 upon n1 square. Okay, so this is your formula. Okay, now see exactly if I'm talking about the spectral line. So see, if you'll try to observe this over here, the spectral lines denoting over here, the first one is your, okay, when I'm talking about the series, okay, it is Lyman series, Balmer series, Bastian series. Okay, so basically when I'm talking about the Lyman series, in Lyman series, what happens that all the atoms jumps from any random orbit to the first orbit. So if they are jumping on the first orbit, they are denoted as the Lyman series. If they are jumping on the second orbit, they are denoted as the Balmer series. Okay, so can I say that this is nothing but a Balmer series question? Yes or no? Okay, so now see, moving on to the Balmer series question. Okay, if you're trying to observe the Balmer series, there is one condition over here. Okay, if I'm talking about the Balmer series, we have the standard wavelength. If you'll try to remember that, the longest and the shortest wavelength for Balmer series. Okay, do you remember or no? Okay, not an issue. Okay, so moving on to that, if I'm talking about the Lyman and the Balmer series and all that, okay, so see, the shortest wavelength for Balmer series, that is shortest. Okay, it is 1 upon lambda is equals to R 1 upon 2 square minus 1 upon infinity square. So this is your equation, and on that basis you can calculate this value as 3646 and stop. Okay, so this is your fixed value. Matlab, in short, they are giving you the value, sorry. So in short, they are giving you the value of lambda is equals to 4 by R, and that is equals to 3646. 4, 6 angstrom. Clear? Okay, now moving on to the question. What exactly is the question is that if I want to calculate the values. So just a sec. Okay. So if I want to calculate the values over here. So if you want to calculate, it is in nanometer. So if you want to calculate the value, so the first option is a 1 upon lambda is equals to r 1 upon 2 square minus 1 upon 3 square. So technically that becomes r 1 by 4 minus 1 by 9. If you take an LCM over here, this becomes r into 5 by 36, or lambda is 36 upon 5 r. Clear? Now we have the value of 4 by r. So can you write like this? This is 9 by 5. Okay, into 4 by r. Or you can go with this 9 by 5 into 3, 6, 4, 6 and strong. Clear? Okay. Now moving on with this, if you will try to solve, this will be approximately 5 ones are okay, or you can go with 1.8. So 1.8 into 3646 will be approximately 600 something. On an approx I'm saying. So basically the answer for A should be third. Okay. Similarly, I can solve for the B1, C1 and D1. And from that you can get the answer. Clear? Okay. Now moving on to the next question, that is question number 16. Okay. Now see, when I'm talking about question number 16, what they have mentioned over here in this particular question, a tightly wound 100 turns coil of radius 10 centimeter carries a current of 7 ampere. The magnitude of the magnetic field at the center of the coil is, the permeability of the free space is 4 pi into 10 raised to minus 7. Okay. To see exactly, a tightly wound 100 turns of coil of radius 10 centimeter carries a current of 7 ampere. So I can simply use that formula now. If I'm talking about, yes, a tightly wound magnetic field at the center of the coil. So I can go with the formula NI. N is the number of turns, I is the current. Okay. And they have given you the radius, so I can calculate the area. Okay, that's it. That is question number 16. Okay, the magnetic field at the center will be. Okay, it's nothing but just a solenoid now. If I'm talking about that tightly wound coils. So it's nothing but a solenoid. So the magnetic field can be given by the formula NIA, where N is your number of turns, I is your current, area, that is pi r square, that is 22 by 7, and r is 0.1 square. The 7 it gets cancelled. Okay, and this particular equation becomes 8 minutes. Just a sec. 100 coils of radius 10 centimeter. So pi r square, I can go with this. The magnitude of the magnetic field at the center of the coil. Okay, do I need to calculate? No, NIA, yes, correct. So I can calculate from this formula. That's it. Okay, now moving on to the question number 17. Now see question number 17, what they have stated. Okay, an output of the given logic is similar to the output of. Okay, so see exactly, if you'll try to observe over here, this particular is a NAND gate. Okay, this one is a NOR gate. And this goes further like this. And it is connected to again a NOR gate. So this is Y, this is A, this is B. So if you want to solve this question, okay, either I can draw the table and then clarify which is the gate, or I can use the concept of Boolean algebra. Now see, when I'm talking about the Boolean algebra, this is dot. So this over here becomes A bar. This over here becomes B bar. Now this is an OR gate. So if this is an OR gate, What exactly this signifies? That A bar plus B bar, and again there is a bubble over here. So this entire becomes a double bubble. So if you try, sorry, a double bar, if you try to break this bar, this gets converted into A double bar plus becomes a dot, B double bar, and double bar cancels out each other. So your final answer is A dot B. So your answer will be and okay, clear everyone? So this is that and. Okay. Now moving on to the next question, that is question number 18. 1, 8. A wire of length L and resistance 100 ohm is divided into 10 equal parts. The 5 parts are connected in series, while the next 5 parts are connected in parallel. The two combinations are again connected in series. The resistance of the final combination will be. So see, exactly the question is very simple, that your total is 100 ohms and it is divided into 10 equal parts. So basically each one will be having a resistance of 10 ohms. Now out of that, the 5 which are connected in series will have a total value of 50 ohms. Okay, we can use that formula NR. And the 5 which are connected in parallel will have the resistance of R by N, that is 10 by 5, that becomes 2 ohm. Okay, now these two are connected in series. So your final answer becomes RS plus RP, that is 52 ohms. That's it. Clear everyone? Yes or no? Okay. Okay. Now moving on to the next question, that is question number 19. Now see, when I'm talking about question number 19, in question number 19, they have given a nuclear reaction. Okay. So what they have mentioned is that in the nuclear emission stated above, the mass number and the atomic number of the product Q respectively are. Okay, so I want to calculate the mass number and the atomic number of Q. Okay, not an issue. So let's talk about this. X, Y, Z, B, and the last one Q. Alpha, okay, positive electron, okay, negative beta, and then again it should be a negative electron. Okay, now moving on to this. This is how much? 290, and this is 82. Now see, if you're emitting alpha, so alpha is nothing but a helium nucleus. So your atomic mass number decreases by 4 and atomic number decreases by 2. So this will be having an atomic mass number of 286 and this will be 80. Now obviously this is electron, this is beta, this is again an electron. So technically, okay, the atomic mass number will now, it won't change. So this will also have an atomic mass number of 286, 286 and 286. Clear? Okay, so your answer should have 286 as atomic number. Okay, now moving on to the next part. Okay, see, one is positive electron and the other one is negative electron. So obviously due to one, the atomic number will decrease, due to the other, the atomic number will increase. So obviously it is balanced, it is 80 only. Okay, now let's talk about the beta particle. So when a beta is emitted, the atomic number increases by 1. So on that basis, your final answer will be 286 and 81. That's it. Clear? So this is your question number 19. Okay. Now moving on to the next question, that is question number 20. Okay. Now see, when I'm talking about question number 20, In question number 20, what they have stated, the maximum elongation of a steel wire of 1 meter length, if the elastic limit of steel and its Young's modulus respectively are 8 into 10 raised to 8 and 2 into 10 raised to 11. So basically, they have given you the value of stress indirectly. That is 8 into 10 raised to 8 Newton per meter square, and Young's modulus Y as 2 into 10 raised to 11 Newton per meter square. So can I use that formula? Y is equals to F by A into capital L upon delta L, or delta L is equals to FL upon AY. Okay. Now, instead of F by A, they have given you the value of stress, that is 8 into 10 raised to 8. Length is 1 meter upon, I can go with 2 into 10 raised to 11. So this gets cancelled, this gets cancelled. It is 10 raised to minus 3. So your total answer is 4 into 10 raised to minus 3 meter. Okay. Or 4 mm. That's it. Clear, everyone? Okay. So this is your question number 20. Okay, now moving on to the next question, that is question number 21. Now see, when I'm talking about question number 21, what they have mentioned over here, if a monochromatic source in Young's double experiment is replaced by a white light, then, okay, interference pattern will disappear. There will be a central dark fringe surrounded by few colored fringes. There will be a central bright, okay, white fringe surrounded by a few colored fringes. All bright fringes will be of equal width. So technically, instead of a monochromatic light, if I'm trying to use a white light, so obviously, if I'm trying to use a white light, what will happen over here is that obviously at the center you will get white fringe, not an issue with that. Okay, so your central will be white. Okay, so central will be white, matlab the first option gets cancelled. Okay, there will be a central dark fringe. The second option also gets cancelled. All the bright fringes will be of equal width. Okay, third option, basically the answer can be third and fourth. Now moving on to the next part, that when I'm using white light, it consists of that will be your violet, indigo, blue, green, yellow, orange, red. So the fringe pattern will be a colored fringe. Okay, when I'm talking about the fringes, the center will be white, but the fringe pattern will be a colored fringe. So technically the answer is actually third option. Okay, clear? Okay, now moving on to the next question, that is question number 22. So 21, central white, okay, with colored fringes. Okay, now question number 22. So 22, at any instant of time t, the displacement of a particle is given as 2t minus 1. So see, they are giving you the equation of displacement, that is 2t minus 1. Okay, under the influence of a force of 5 Newton, that force is 5 Newton. So they have mentioned that the force is constant. Okay, the value of instantaneous power. Now see, if I'm talking about the power, we have that formula. That power can be given as dW by d. So I can go with this, okay, dW by d. Or we also have that formula that power is nothing but force into velocity. Now see, if you try to differentiate displacement, velocity is ds by dt. Based on that, d by dt of 2t minus 1, that is equals to 2 meters per second. Okay, so the force is 5, velocity is 2, so your power becomes 10 watts. Clear? So this is your question number 22. Okay, now the next one, that is question number 23. Now see, when I'm talking about question number 23, what they have given in the question is, consider the following statements A and B and identify the correct answer. So this is your voltage and this is your current. Okay. For a solar cell, the IV characteristics lies in the fourth quadrant. Okay, the fourth quadrant means this one. First, second, third, and fourth. In a reverse bias PN junction diode, the current measured in microampere is due to majority carriers. Obviously, reverse bias, the current will be due to minority carriers. So definitely B is incorrect. Confirm. Okay, so B is incorrect. We have first option, second option, third option, and sorry, fourth option. So your answer can be first, second, and fourth. Now moving on to the first one. Now see what they have mentioned in a solar cell. The IV characteristics lies in the fourth quadrant. The fourth quadrant means what? That your potential will be positive and your current will be negative. So obviously what happens in a solar cell? That it is not connected to a battery. It itself behaves as a battery and it generates a current. Okay, that current is because of the movement of the majority carriers. That, for example, if I'm talking about this as your N-type semiconductor, this as your P-type semiconductor, and for example, this is the depletion layer between them. They two are connected with a wire. This is N-type, this is P-type. They are connected with a wire, and over here I'll be keeping a resistance. So across this resistance, you will find a potential difference and current. Basically, the solar cell itself behaves as a battery. So obviously the VI characteristic will be in the fourth quadrant. Okay, so your statement 1 is correct and statement 2 is incorrect. Based on that, your answer will be the first option, that A is correct and B is incorrect. Clear? So A correct. Okay. So any doubt in this? Okay. Now moving on to the next question, that is question number 24. Now see, when I'm talking about question number 24, okay, two bodies A and B of same mass undergo completely inelastic one-dimensional collision. Okay, the two bodies of same mass undergo completely inelastic. Completely inelastic matlab E is equals to 0, or on that basis I can say that after collision they move together. Okay, the body A moves with a velocity of v1 while the body B, okay, is at rest before collision. The velocity of the system after collision is v2. The ratio between v1 upon v2 is, so, 2 by 1. See, now how exactly 2 by 1? That we know that E is equals to, okay, change in velocity after collision upon change in velocity before collision. So obviously this change is 0. Okay, so this will be v1 minus 0. Okay, so based on that we get that formula that E is equals to 0. No doubt about it. This is correct. Okay, now moving on to the conservation of moment. That is M1V1, M1U1 plus M2U2 is equals to M1 plus M2 into. So this is 0 now, as U is 0. So basically this becomes MV1 is equals to 2MV2. So M and M gets cancelled. So we can have V1 upon V2 is equals to 2 by 1. And this becomes your formula. Clear, everyone? Okay. So now moving on to the last question over here. Okay, remaining questions we'll solve in the next lecture tomorrow, same time. Okay, whatever we have, the same questions we'll be solving tomorrow. So the last question, that is question number 25. Now see what is exactly question number 25. We have shown a graph. Okay, and the graph is 1 upon lambda square. Okay, and kinetic energy. So 1 upon lambda square and kinetic energy. Okay, where E is kinetic energy and lambda is d Broglie's wavelength of a free particle. So see, when I'm talking about the wavelength, so lambda is nothing but, if you remember, h upon p, or you can also go with h upon the root of 2 kinetic energy into mass. Or let's say that if you just ignore this, if you remove the square, this becomes lambda square is equals to h square upon twice of kinetic energy into mass. Or exactly, lambda square is inversely proportional to kinetic energy. So 1 upon lambda square is directly proportional to kinetic energy. So obviously, if 1 upon lambda square is directly proportional to kinetic energy, so the graph between them will be a straight line. Okay. So this will be your answer. The graph between them will be a straight line. So in the next session, we'll continue with your question number 26. Okay. Moving to question number 50. Done? Chalo. Till then, enjoy everyone. Okay. Chalo. Bye-bye.